You're on a job site. The electrical contractor pulls you aside and says the panel is undersized for the load. The owner wants to know what that means for the budget and the schedule. Do you know what to say? If you've never opened an electrical drawing, never heard of Ohm's law, or never thought about what a circuit actually does, you're going to get lost fast. And on a real project, getting lost in an electrical conversation is expensive. This video fixes that. No engineering degree required. Electricity is 15% or more of your trade contractor budget. You need to speak the language. Here's what most people don't realize about electrical on a construction project. The electrical contractor is the first trade in and the last trade out. They set up your temporary power before anyone else can work. They're still finishing life safety systems when almost every other trade has packed up. Their scope covers more than most people expect. Power and distribution, yes, but also emergency systems, telecom, fire alarms, security, AV, HVAC controls, and lightning protection. If it uses electricity or sends a signal, they own it. And in Boston right now, a union electrician runs over $100 an hour burdened. Multiply that by a crew of 10 over 6 months. Labor efficiency on electrical work can make or break your project budget. So when your electrical sub walks up with a problem, you need to understand it, not just hand it off to the engineer and hope for the best. You don't need to be an electrician. You need to understand 4 things: voltage, current, resistance, and power. Everything else in electrical systems builds on these. Think of it like water moving through a pipe. Voltage is the pressures, it's what pushes the electricity through. Current is the flow rate, how much electricity is actually moving. Resistance is a constriction in the pipe, it slows things down. And power is the result, the work that gets done. In real units, voltage is measured in volts, current in amps, resistance in ohms, power in watts or kilowatts. Those 4 variables are connected. Change one and the others change with it. That relationship has a name, Ohm's law, and it's the foundation for almost every electrical calculation you'll encounter in the field. Ohm's law says voltage equals current times resistance, E equals I times R. That's it. What makes this useful on the job is that you can solve for any one of those 3 variables if you know the other 2. Cover up the one you want to find, and the remaining 2 tell you the formula. Here's a real example. Your electrical sub tells you a heating element in an air handling unit has 3 ohms of resistance and draws 4 amps. What's the voltage it needs? Voltage equals amps times ohms, 4 times 3, that's 12 volts. Now flip it. You know the voltage is 12 and the resistance is 3. What's the current draw? Current equals voltage divided by resistance. 12 divided by 3, 4 amps. You are not doing the electrician's job when you run these numbers. You're doing yours, verifying that what's on paper matches what's being installed, and catching discrepancies before they turn into RFIs and change orders. Power is where electrical knowledge hits the budget. The power formula says power equals voltage times current, P equals E times I. On a 120 volt circuit with a load drawing half an amp, that's 60 watts, your standard light bulb. Simple. Now scale that up. An industrial HVAC unit running at 480 volts drawing 20 amps is 9,600 watts, almost 10 kilowatts. Run that for 8 hours a day and you're burning through 80 kilowatt hours. That's a line item on the owner's operating cost. Here's the version that matters most for safety and construction. Power dissipated as heat equals current squared times resistance. If current doubles, heat quadruples. That's not a math exercise. That's why undersized wire causes fires. That's why breaker sizing matters. That's why your electrical sub gets irritated when someone tries to add a load to a circuit without checking the ampacity. When you understand power, you understand why electrical decisions aren't just technical, they're financial and safety critical. Let's make this concrete. Here are 3 situations where this knowledge pays off. First, the budget conversation. When an electrical sub hands you a change order saying the panel needs to be upsized, you can now ask the right questions. What's the new load in kilowatts? What's the difference in ampacity? Is this a design issue or a scope change? You can have that conversation instead of just signing the paperwork. Second, the safety walkthrough. Temporary electrical on a job site is one of the leading causes of construction fatalities. When you understand that resistance, damaged insulation, and overloaded circuits create heat, and heat creates fires, you stop seeing extension cords and temporary panels as background noise. You start seeing hazards. Third, the certificate of occupancy inspection. Electrical inspections are mandatory milestones before you get your CO. Rough-in inspection, final inspection. Miss one and you're delaying turnover. You don't run those inspections, but you schedule them, coordinate them, and make sure the sub is ready. You can't do that if you don't know what the inspector is looking for. Electrical knowledge doesn't make you an electrician. It makes you a better construction manager. Voltage, current, resistance, power. Those four variables and the two formulas that connect them, Ohm's law and the power formula, give you the foundation to read electrical documents, ask better questions, and catch problems before they cost you. You don't need to design the system, you need to manage it. And now you have the language to do that. If you want to go deeper, prompts you can use with AI tools to work through electrical calculations, those are in the resources at ProfPeaks. Link is on screen. ProfPeaks, practical tools for construction management students and professionals. profpeaks.gumroad.com.